Okay, now we're going to learn something called normal as approximation to binomial. Normal as approximation to binomial. We know both of these distributions. Now, first of all, what is a binomial distribution? For the binomial distribution, it's a discrete probability distribution. And if you remember that, we have a fixed number n trials. And then for each trial, the probability of success is p. And the other one will be q, right? The fail has 1 minus p, this much probability. And we can look for what is the probability of x, if you remember. And that will be, we're going to choose x from n, and then the p to the x, and a 1 minus p to n minus x. It's like a quick review, okay? So this is n factorial, here is n minus x factorial, and x factorial, and a p x, and here you can write q. It's the same thing as 1 minus p and n minus x. So this is a formula to calculate p of x, and here this x could be 0 or 1 or 2 or all the way to n. Therefore, this is the binomial probability distribution. That's what we learned in earlier chapters. And also, there's another thing we learned is the mu, which is the mean of this binomial probability distribution, is n times p, right? And the standard deviation is the square root of npq, or you write n times p times 1 minus p. So this is everything we learned for binomial. And after we calculate the p of x, which is the probability of x equals from 0 all the way to n, we can get a histogram, right? So here is the probability p of x, and here we have a 0 and a 1 and a 2 and a 3 and all the way to n. All right, in a lot of cases, you're going to see here is a histogram. Okay, I just draw that. Okay, things like this. All right, now in this section, what we're going to know is, what I want to tell you is, if there are two conditions. So the first condition is np is greater than or equal to 5. Okay, and the second condition is nq is greater than or equal to 5. Do you remember what is np? np is mean, which is the average or expected number for this distribution. If that is greater than 5, which means your mean or the highest bar of your histogram will not occur very close to this side, to the 0, 1, 2, 3, because it's going to be greater than or equal to 5, so it's going to start from 5 or more. And this one, this nq greater than or equal to 5, which means the highest bar is not going to be too close to the right side. Okay, so in this case, then when you draw the histogram, you're going to have something look like, and we can look that as, well, it's approximately normal. That's what it says, okay? That's why these two conditions. If you want to use normal as approximation to binomial, those are the two conditions you always have to check. However, the next thing is, when we deal with a binomial probability distribution, our x is either 0 or 1 or 2 or 3. They're whole numbers, right? But if we want to use normal as the approximation, there's a problem, because the normal distribution is a continuous distribution, isn't it? Therefore, we have to do something. It's called continuity correction. This is a new term that I hope that you can understand. This continuity correction. What does that mean? Okay, that means for the binomial, if x equals, for example, equals 6, all right, we can draw the bar, right? The histogram here is a 6. And the next one will be 7. And then before that will be 5. So instead of having this, all those isolated bars or just a vertical line, I am going to expand this to the left and the right by 0.5. So I would get this. Okay, so that is from, here's a 5.5, right? Here. And here it's a 6.5. So I will get this number 6 from the binomial probability distribution, that variable x. I'm going to go plus and minus 0.5 to get the width of 1, to get this bar or this histogram, that width is 1. Then look at what happened when x equals 7. And that will be from 6.5 to 7.5. Again, from this 7, I expand to both sides by 0.5. So I will have something look like this. Okay, by plus 0.5 and minus 0.5. Then all my x value from 0, 1, 2, and all the way to n becomes what? Becomes negative 0.5 to 0.5, and then 0.5 to 1.5, and a 1.5 to 2.5. Well, this is our 0, this is our 1, this is our 2. But the good thing is I make that continuous, isn't it? See, this one goes from negative 0.5 to positive 2, positive 0.5, and then from 0.5. See, they're connected. See, that's right here. And then from 0.5 to 1.5, and then the next 2 becomes 1.5 to 2.5. Now you get the idea is for every number, the whole number, which is that x, the random variable, discrete random variable, in your binomial probability distribution, by expanding that from that number minus 0.5 to the number plus 0.5, I will get a continuous variable. Seems like a continuous, right? Then I can use binomial because I know the mean, I know the standard deviation, then I can use binomial. That's what I say. So it's called a continuity correction. All right, those are the most important thing when you use binomial, when you use normal as approximation to binomial. All right, now I will give you one example. Okay, we use this example to understand this. In one of the Mendel's famous hybridization experiments, he expected that among 580 offspring peas, I didn't write the whole sentence, but I just read the most important ones, offspring peas. Okay, what happened is we found 145 would be yellow, okay, that is 25%. Okay, so out of all those peas, should be 25% of them, 25% of all those peas should be yellow. However, but he actually got 152, so he only have, well, not only, he has 152 yellow peas. Assuming that Mendel's rate of 25% is correct, find the probability of getting 152 or more yellow peas. I'm looking for this. Okay, what is the probability that you're going to have? You're going to have 152 yellow or 152 or more yellow peas. All right, now this is n, right? So your n is 580. Okay, and for each p, is going to be either yellow or not yellow. So 2 possible outcomes. Okay, is that right? 2 outcomes. Yellow, not yellow, which means green. Okay, and for each outcome, the probability of each yellow equals 0.25 or 25%, and that doesn't change. All right, and each P, whether it's yellow or green, they're independent of each other. So independent. So we have a fixed number of trials and 2 possible outcomes. Success rate stays the same for each trial, and each trial is independent of any others. So this is a binomial. How do you find what is the probability you get a 152 or more, a yellow? X is greater than 152. That's what you're looking for, right? 152 or more, which means including 152. So you're looking for that. If you just use the binomial probability distribution, you should have the probability of 152 plus the probability of 153 plus the probability of 154 and all the way to the probability of 580 of them. All of them are yellow. This is what you should do if you just use the binomial probability distribution to solve this problem. However, we don't want to do that. Of course, like when we talked about the binomial probability distribution, and there's a lot of tools online. You can Google it. You can Google binomial probability calculator, and then you're going to enter x equals 152, n equals 580. The probability is 25%, and then you click calculate. It will give you some calculators will give you the probability that the x is 152 or more. Okay, so you can do that. And we can also use normal. We can also use the normal probability distribution as the approximation of it. How should we do that? First of all, we decide to do that. Then we write down n is 580, and then we have the probability is 0.25. That's the probability of being yellow. And then we can find a mean and a standard deviation. But before that, keep in mind there's one thing you have to check. You have to check, okay? I want to see you write this in your quiz. So you're going to check NP, which is 580 times 0.25, and that equals 145. That is greater than or equal to 5. Remember, this is what we're looking for, whether this number is greater than or equal to 5. And also, please check Q, NQ. So that's 580 times 1 minus 0.25, all right? And that answer is 435. It's also greater than or equal to 5. So, yes, these two requirements, they are met. Therefore, we can use normal distribution as approximation of the binomial distribution. I really need to see this in your quiz. You get credit for that. If you don't write this down, I cannot give you credit. All right, now that's the first step, okay? I want to see the second step. I need to get the mean and standard deviation. And the mu is NP, and which is, we already know that, it's 145. And the standard deviation is NPQ, then square root. So that will be 580 times 0.25 times 0.75, because Q is just 1 minus P. Let me find the answer. Sorry. So if you have this calculator, then you're going to do, I write here, So it's a 580 times 0.25 times 0.75 equal, that's 10, that's 108.75, and then take a square root of it. So here is the square root. Okay, ding, I get a 10.43. So the standard deviation is 10.43. All right, so we have the mean, we have standard deviation. Step 3, draw the curve. I want to see the graph. Here's a 0, here's a z, because we're going to use a standard normal distribution. However, for the x, we have the mean, we calculate that, which is 145. Okay, and the standard deviation I write at the end, which is a 10.43. Okay, what we're looking for? We ask for what is the probability 152 or more equals. Okay, we have to do that continuity adjustment. Continuous adjustment. I hope that you can do this. For you draw a little number line, you write 152, okay? And you also write 151, which is the one number less than that, and 153, one number greater than that. Where is your 152? Remember, we have to expand this by 0.5, so from here to here, we call that 152, isn't it? Okay, so when we talk about 152 or more, that means including 152 or more all the way to the right. Do we get here? That's including 152, so starting from 151.5. So that would be the probability that x is greater than 151.5. All right, so from 152 or more, so 152, and this is 153, and the next one 154, and so on. So 152 actually starting from 151.5 and all the way to the right. Okay, so we have this x greater than 151.5. I just write it here because I don't know exactly where is that, but I know it's to the right of 145. Can you find the z-score for it? See, here is missing, right? We're looking for z-score. The z-score will be just x minus mean divided by standard deviation, which is like universal. So that is 151. We're looking for the z-score for 151. And we're going to use that minus 145 divided by standard deviation, which is here, 10.43. All right. So if you use the little calculator, 151.5 minus 145, which is 6.5, so you get 0.62. For z-score, you keep 2 decimal places, so that's 0.62 here, 0.62. All right, so the probability that x is greater than 151.5 is this little area, which is equivalent to z greater than 0.62. When you get to this point, then you can use the z table. Again, there are 2 ways to do it. One is you look at a 0.62 in the positive z table, so you can get the area all the way to the left of this line, and then subtract this white area from 1 because the area under the curve is 1. Or you just simply use a negative 0.62 to get the tail area, this little area to the left of it, which is equivalent to, or exactly, because it's symmetric, exactly the same as this probability that z greater than 0.62. And you're going to get the answer is 0.2665. That is your answer. Okay, so that's this 0.2665. That's your answer. Okay. Now, when we go back to talk about this probability distribution, the continuity correction. If I say x is greater than, okay, in English, I said 152 or more. So I would go 152, again 151, I repeat this, okay, and 153. So 152 is actually here, right? From here to here, you can shade this line. And 152 or more, so that's from here. So you should look for x greater than 151.5. Make sense? Okay, so if I say more than 152, again 152, here's 151, and here's 153, and this is your 152. But when I say more than, that means if 152 is no good, we're not going to include 152. More than 152, we're going to start from 153. So we're going to do this. So that's going to be the probability of x greater than 152.5. I don't want you to remember things like x or more. You just go x greater than the number minus 0.5. And here more than that, you just go greater than plus 0.5. I think just by draw this number line, make it much easier to see whether you should plus or minus 0.2 when you do this calculation. Now next one, 152 or less. Again, on this little number line, you write 152 and write the two neighbors, 151 and 153, and you put little thing here, and that is your, after you did the continuity correction, that's your 152. So when you look for 152 or less, which means from 152 all the way to the right, to the left, so you should start from here. Okay, that should include 152. So that would be x less than 152.5. Okay, and when I say less than 152, again 152, 151, 153, and this is my 152, right? And the less than that means we cannot include that, and the less than is to the left, so it should be 152 to the left, but after we do the continuity correction, it should go starting from here, and that is 151.5. So that would be, you're looking for the probability that x is less than 151.5. Okay, see, those are the 4 different situations, and I don't want you to just purely remember, just simply remember you should add or subtract a 0.5. I think just draw this little number line will help you a lot. Okay, and if you want to use, like if you have, I think the Star Trek or some other calculators, you're going to find pretty much the same conclusion or same answer, 0.25. What's the answer? I got 0.2665. All right, now we're going to work on the second example. Example 2. Okay. Suppose a local kindergarten through 12th grade, which is K-2, K-12 school district, 53% of the population favor a charter school for grade K through 5. So they favor a charter school. Okay. A simple random sample of 300 is surveyed. That's your sample size, 300. All right. So you randomly select 300 people. You ask him, are you in favor of a charter school? Do you favor a charter school? He's going to answer you yes. He's going to answer you no. So 2 possible outcomes for 300 total trials. And each one's answer is independent of others. And also the probability that they're going to answer yes is going to be, that's your P, it's 0.53. It stays the same for every single objects or every single person you asked. So each one has the same probability that in favor of a charter school. So this is a binomial, right? It looks like it satisfies the 4 requirements. Okay, so I'm going to ask you the following question. Number 1, find the probability that at least 150 favor a charter school. Okay, at least 150. Number 2, probability that at most 160 favor a charter school. I'm not write this down. Number 3, what's the probability that more than 155 favor a charter school? Okay, and number 4, what's the probability that fewer than 147 favor a charter school? And the last one, what is the probability that exactly 175 in favor of charter school? All right. We check, right? We check NP, NQ, and to see whether we can use normal as the approximation to binomial. Okay, so we check NP, which is 300 times 0.53. That is 159. It is much greater than 5. So it's greater than or equal to 5. And NQ will be 300 times 1 minus 0.53, which is 300 times 0.47. That's 141. And it is also greater than or equal to 5. So both conditions are okay. Therefore, we can use normal approximation to binomial. Okay, so let's quickly talk about this. Okay, so here's 150, and here's a 49, and here's 151. What is at least 150? At least 150 means 150 or more. So here is your 150, right? After you do this continuity correction. So at least 150, which is starting from 149, that's the probability that x greater than 149.5. Okay, and this one at most 160. So here's 160, and of course this is 161. Here's 159. What does at most 160 mean? At most means 160 or less. Okay, it could be 160, so it could be here or less. So you are looking for the probability that x is less than 160.5, right? Okay, now this one, more than 155. So here's 155, 156, and 154, and here is your 155, right? When we say more than, means it has to be more than, has to be at least 156. 155 will not be included, so it's going to be like that. So this is the probability that x is greater than 155.5. And then fewer than 147. See, I'm doing this very quick, right? So it's 146, and here is our 147. Okay, and a fewer than that means if 147 cannot be included, and it's going to be, because fewer means less than, to the left. So that is the probability that x is less than 146.5. Okay, now this one is tricky. Exactly. If you remember when we talk about the normal distribution, it's a continuous variable, x is continuous variable. So here, if you write x is greater than or x is greater than or equal to, it doesn't make any difference, right? Because it's continuous variable, and the area under the curve shows the probability. If you just have x equals to exact one number, and that's going to be just a vertical line. There's no area, so that should be 0. However, for this one, when we talk about 175, and again, you always write the neighbor two numbers, exactly 175, which is here. So that is the probability that x is between 174.5 and 175.5. So we're looking for here. We're looking for this area on top of these two values. All right. So first of all, I think we did check this, and the second one we figure out the continuity correction, so we know exactly. And the next one will be very simple. We get a mu, which is n times p. We have it. It's 159, and the standard deviation will be 300 times 0.53 times 0.47, which is NPQ, and then you take the square root of it, so you get 8.64. I think that's okay. If you want to keep a little bit more decimal places, that's totally fine. All right, now we are going to draw the curve. Here's a 0, z. Okay, and we're going to have 159, and here is x, and the sigma is 8.6447. Now, we look at the first question. At least 150 favor a charter school. We should find the probability that x is greater than 149.5. Where is 149.5? Which is here. So it's 149.5. So we're looking for this area. And then the rest will be very simple. We look for the z-score. So the z-score will be 149.5 minus mean, because it's to the left of the mean. I know I'm going to get a negative z-score. And divided by 8.6447. So my answer here is negative 1.10. And here's negative 1.10. And then you can look at either the negative z-score to get this little area, subtract that from 1, or you just look at the positive 1.10, and then the area to the left of a positive 1.10 is the same as the area to the right of a negative 1.10. So the probability of x greater than 149.5 equals, I look at the table, should be 0.8643. Okay, I'm not going to continue to finish all of those, but I think you already got the idea how to do this. First thing, you're going to check whether you can use the normal as approximation to binomial first. And the second, of course, you can get the mean standard deviation. And the third, I did that early because I figure I have a little space here. So you do the continuity correction, and then the rest will be just like what we learned in the earlier sessions, how to do the normal, how to figure out the area of the any normal probability distribution under the area under the curve. Okay, so I think that's everything you need to know about the normal approximation to binomial, normal as approximation to binomial. Okay, so this is going to be in your quiz. I think right now you're okay to do more exercises and to work on the homework.